So 2021, we did a big roundup at the end of 2021, and one of the big things that we talked about then was the impending launch of the James Webb. And I guess we were all, I mean, everyone, I think, in the entire scientific community and the astronomy community was doing this and crossing everything and hoping that it all worked. And to quote Jeff Goldblum in Jurassic Park, "You crazy fool, you've gone ahead and done it." They did it. It's up there. It's moving out to its Lagrange point. It's unfurled the sun shield, tensioned the sun shield. It's quite amazing. And from my perspective, it's a long story, this. And loads of people have talked about the James Webb, and we're going to talk about the James Webb for a good while tonight. Talk about the instrumentation and what it's going to be doing and stuff. And Terry's going to be covering all of that rather brilliantly, I would imagine. From my perspective, it's quite a personal story, because around about 10, 11 years ago, I was in New York at a conference called the NEAF Conference, Northeast Astronomy Forum. And it's like a big astronomy event that's hosted by several of the magazines, and lots of people are there. The Meteorite Men are there, and lots of the telescope vendors and what have you. It's a really, really good show to go to if you ever get a chance. It's up in a place called Suffern, just north of New York. And one of the speakers there was a lady called Dr. Heidi Hamill, and she's been very, very involved, as has people like John Mather, who's the PI on James Webb, and Amber Strawn and various other people, been involved for decades. This is most of their career involved in this. But 10 years ago, there was a real threat that the James Webb was going to be cancelled. Congress were not happy with the overspend, and at the time it wasn't even anywhere near what it is now, but they were really trying to look at where they could cut various programs. And we saw throughout the Obama administration, for example, the cutting of some of the proposed lunar lander programs, etc. with that. And Congress have got a really heavy scythe on this, so lots of people got involved. So Barb Mikulski, pardon me if I pronounced the name incorrectly, but one of the senators based up in Maryland, who one of her remits was the Hubble, she got heavily involved. So during Heidi's talk, she basically said, look, please talk to your Congress people and get involved, because there's a real threat that this thing could be cancelled. So I kind of took this message back to the UK and got in touch with a journalist friend of mine called Paul Sutherland, and he got it into some of the national press that there was a plan to cancel this telescope. And then a group of American friends got in touch and said, look, do you want to join in? We're going to set up a campaign called Save the James Webb. And it became this like group of about 8 or 10 of us got involved, and we pushed really hard. We pushed via all the social media channels at the time. It's nowhere near as busy as it is now, but via Facebook and Twitter in its infancy, etc., and really just pushing the message that write to your congressperson. And thousands of people did, and we got a thank you. We got a one. It was kind of saved. We all got an email from NASA head office, as it were, basically saying, would you like, as our way of saying thank you, to come to Goddard to see the thing being built, to see the thing being put together. And for the Americans, it was great. For me, it was like, this is a chance in a lifetime kind of thing. So it took about 3 months, because you got it's a government facility, NASA Goddard, etc., and to get all the clearances and stuff. But flew over to Washington, stayed with some friends in Washington, and just spent the most amazing few days touring Goddard Space Flight Center, going inside the various facilities, looking at the test and vacuum chambers, etc., and seeing the mirrors kind of just all, the whole system being put together. And you just think, 10 years ago, it was still, nobody knew if it was going to be launched. Even up until not that long ago, we didn't even know if it was going to be successful in launch. And then all of the risk associated with it, with ESA doing the launch with the Ariane, and the Ariane, it's quite a reliable system, but it's not 100% reliable. And getting off the ground, and then the fact that the James Webb could never be fully tested on the ground because it's too big. You always say it's a tennis court size sun shield. To integrate that with the main telescope array and the main mirror array and all of the instrumentation, it was actually impossible. There wasn't a vacuum chamber on the planet big enough to test it in its full configuration. So it had never been tested fully. And even up until a few days before launch, there were still issues where there were joists kind of not supporting things. It's a miracle. It's an absolute miracle. And now that it's heading out there, what's it going to do for us, Terry? What are the amazing things this telescope is going to do?
Well, a lot of people wonder why it's going to operate mainly in the infrared. We all like the lovely pictures from the Hubble Space Telescope and the other Earth-based telescopes and so on. We will get some from the James Webb, but not quite the same sort of thing. The reason it's going to operate mainly in the infrared is that it wants to look back as far as possible towards the very birth of the universe, the Big Bang, and what happened immediately afterwards. And there are a number of issues there, but the main one is that that is so far away, and the light, all the radiation, in fact, because of the expansion of the universe, has been stretched, what we call redshift. And most of the light that is coming to us from the events in the very early universe has been stretched from the visible well into the infrared. So to look at the galaxies and the first stars as they were about 13.5 billion years ago, you need to be able to see into the infrared. So it will be looking at the birth of the first galaxies, the birth of the first stars. Even closer to home in our own galaxy, there's an awful lot of stuff in our galaxy that we can't see properly because it's obscured by dust. And infrared light penetrates through dust. So you can see the very early stages of planetary formation of the protosolar disk surrounding stars and see just how stars first form. We'll also be able to look at a lot of things even in the outer region of our own solar system in the Edgeworth Kuiper belt, maybe even out as far as the Oort cloud, where things are they're so cool that they are radiating or reflecting in the infrared rather than invisible light. So a whole lot of things that the James Webb can study that we can't study at all from the Earth because the infrared radiation doesn't get through, but that even the Hubble Space Telescope wasn't able to study. There were other infrared satellites up there, nowhere near as powerful as the Webb. Some of them have reached the end of their life anyway. So there's so many things that this telescope will be able to do that no other telescope can do, that it's just going to be groundbreaking, assuming, of course, that everything actually works as planned. It's on its way almost at the Lagrangian point, the L2 point, where it's going to be stationed. That happens, I think, in about 4 or 5 days, 23rd of January. But all the instruments still have to be fully tested. And most importantly, the final collimation of all the 18 different segments of the main mirror have to be exactly collimated. And this is something to try and get your head around. The surface accuracy of all 18 of those mirrors working together has to be accurate to the diameter of a coronavirus. Nanometers, about 10 nanometers. I mean, it's mind-boggling, and this all has to be done remotely. Now, because there are 18 different mirrors and they all have to not only be individually adjusted, but then to work as one, that is going to take quite a while. We're not going to get nice pictures back just as soon as it gets to the L2 point. We have to be patient. There's no point in sending back very blurred, disappointing pictures, although they will send some pictures back just to make sure that the optics are working and the transmission system is working. But we'll not get really clear pictures probably until around April or May. But if everything works as it's supposed to, this is going to just totally revolutionize whole various areas of astronomy, mainly what I've already talked about. There's a lot more. We could talk about this all night. Those are the main things. What do you think, Nick?
I mean, yeah, it's amazing. We talk about collimation with telescopes, and any amateur astronomer who's ever tried to collimate a Schmidt-Cassegrain or a Newtonian telescope will know it's mirror alignment is really important for getting really crisp, sharp images. And we all remember what happened with Perkins Elmer with the Hubble Space Telescope and the fact that they ground the mirror incorrectly. Thankfully, with this, it's as Terry said, it's a multitude of mirrors. The accuracy, the surface accuracy on the mirrors themselves. I mean, you're talking about atomic level thicknesses of gold, obviously being the most optimal material for picking up the light in the infrared end of the spectrum, which is why it was selected. And people say, why are the mirrors gold? Well, it's optimized around the frequencies of light that it's aiming at. It's things like the Oort cloud. At the moment, the Oort cloud is a theoretical. We believe it's there, but we've never seen anything in it. So could the James Webb finally show us objects in the Oort cloud? Could it pick up this hypothetical planet X that everyone's
Mhm.
been saying is out there? And then you've got the whole argument of, well, if it's above a certain size, is it a planet or is it a moon? And the whole issue is surrounding that. But there's another potential. The whole thing with exoplanet atmospheres, the fact that you could detect not the presence of life, but the signatures that would indicate that there could be life on a planet. From the atmospheres of exoplanets on nearby star systems. We know that Proxima Centauri's got multiple planets in it orbiting around it. That's just one star. There's thousands and thousands been picked up by Kepler. So there's the whole cosmic dawn and star formation and galaxy formation, like a few 100 million years after the Big Bang. We may have to completely rip up the textbooks again in terms of what we believe on galaxy formation. There's so much that is riding on this, and the fact that the European Space Agency, and everyone says, oh, it's a NASA, NASA's website.
Yeah.
It isn't. This is a joint mission between NASA and ESA, and a huge amount of credit has got to be given to the European Space Agency, between the Ariane team, and the launch system being absolutely flawless and being so perfect that they've extended the actual lifespan of the James Webb even further because their orbital insertion precision was so good. So massive hat tip on that one, and there was loads of people really concerned. I was one of them. How concerned about that, I was. But then, the instrumentation, it's a global effort that's gone into this. Edinburgh University and all sorts of places all over the UK and all over the world have really collaborated. So there's hundreds or thousands of scientists have worked on this. As I said, people like John Mather, who's the PI, this has been 23, 24 years of his life.
Mhm.
And with the delays and delays and delays, this thing initially was scheduled to launch like pretty much 10 years ago, or getting on for 10 years ago, but we've had so many delays. It's like Artemis. It's going to be incredible. The thing with infrared as well that we need to be aware of is that the Hubble images are beautiful, and Hubble images were truly beautiful because not only was the data and the quality of the data coming in and captured so good, and let's not forget that the computational capability and the imaging sensors on the Hubble are now decades old. These are not state-of-the-art sensors. Even the James Webb, the instrumentation on it is going on for a decade old because some of this stuff was conceived and had to be approved and signed off way before launch. Some of these instruments have been ready for years and have been almost in cold storage, kind of ready for deployment. So if you take all that into account and then you look at some of the images coming back from the Hubble still to this day that are absolutely remarkable, and we can only hope that SpaceX or somebody is going to be able to deliver a capability to repair the Hubble yet again, or do something with it, at least put it into a higher orbit until we can work out what to do with it. The thing that always struck me was, and it was a great quote from a magazine editor that I used to work with, who said that the Hubble's images are beautiful, but the ESA Herschel images look like somebody's thrown up on a dinner plate. The colors were all over the place. Now, this is the problem with infrared, obviously at the kind of longer wavelength end. The resolution that you're going to get from an instrument the size of the Hubble compared to the Hubble, which is operating into the ultraviolet and the optical end of the spectrum, some minor bit into the infrared, is going to be nowhere near as crisp. But with the James Webb mirror being so much bigger, those images are going to be crisp, and hopefully the image processing, you're going to want to get as much science from it, but the public at large are going to want to see beautiful images. They're going to want to see the pillars of creation, as it were, or the Horsehead Nebula. Some of the images that came out of Herschel were stunning, but some of them really did look pretty awful, and people were like, what is this? Why have we put so much money into this? So I know NASA will do this, and I know ESA will do this. You've got to be able to deliver not only fantastic science, so detection of exoplanet atmospheres, detection of Oort cloud objects, etc., all of these wonderful things, but if you just show a little tiny red dot on the screen and say, this is the furthest star we've ever seen at 13.18 billion light years away, people are going to go, meh. If you show them an image like the Pillars of Creation, they're going to go, wow. And that's what I hope it's going to do as well, is not only inspire people from a scientific point of view, but inspire people, in the way that the Hubble did. The Hubble is almost like it's a common word in our language now. It's like Google.
Mhm.
We talk about telescopes, we talk about the Hubble, and we don't, we know that Edwin Hubble was, a historic figure, etc. And there was all the controversy, don't forget, just before James Webb was launched,
Mm.
with the whole cancel culture thing that's going on. Of, oh, should it be named after James Webb because of his beliefs and views? Well, it's like anything that's in our past, we need to learn by our mistakes and move forward. And James Webb, for all of his failures, and everybody has failures. My kids remind me daily that people like Gandhi was this and Martin Luther King was that. Nobody's perfect, but James Webb got us to the moon. It was absolutely incredible, and that's what we need. Can
I
you
got a
still
wee
hear me?
error message there, but I'm still hearing you.
Yeah, still hear you. Good.
Right.
Got a message.
Just you're talking about the international aspect, and I'm delighted to say that one of the principal or co-principal investigators on the MIRI instrument, the mid-infrared instrument, is actually a guy I know well from Dublin, and he's giving a lecture to us, the Irish Astronomical Association, on the James Webb tomorrow night. So that'll be very timely. But the instrument that he's involved with, the MIRI, the amazing thing about that is it'll be operating at only about 7 degrees above absolute zero, because that's where you need basically to have your greatest sensitivity. And how do they achieve that? That's where the big sun shield comes in. And this is one of the mind-boggling things about that. The temperature difference between the sunward side and the shaded side on the final layer is 347 degrees centigrade. 347 degrees C, not Fahrenheit like the Americans like. That is the amount of shielding that sunshade will provide. And then there's obviously a helium refrigeration system basically to cool down the MIRI instrument, in particular, even cooler than that. But that sunshade, which they say as well known, really, the size of a tennis court. And of course, that all had to deploy on the way out. This is where we were biting our nails and so on. And then the mirrors unfolding. And we just couldn't believe it that everything was working so perfectly. Now, I hope that's not putting the curse on it, because there are other things still to happen. Yeah. But basically, so far, everything has worked just like textbook. And it's full kudos to everybody involved.
Yeah, it's flawless. The level of testing that was undertaken. And that sun shield, those layers that are the size of a tennis court, are also about the thickness of a human hair. I mean, It's ridiculous. It's like, the thinnest sheets of kind of Bako foil you can imagine, as it were, but vastly, vastly thin. I mean, it's literally whisper thin. And to be able to tension it in multiple axes and get it, all of the separate layers, spaced perfectly, deployed perfectly. It is an absolute marvel. And the fantastic thing as well is that even amateurs, and we're going to be talking about this a bit later with people getting telescopes for Christmas, even amateurs have been able to image this thing as it's been heading out. Yeah. And the beauty is, as it's been getting bigger, deploying the sun shield and deploying the telescope array, as it were, its brightness is changing. It's an absolutely remarkable thing to see. And some of the images, even, you could see that it wasn't a stellar object. You could see that it wasn't round. It was an elongated shape. So again, hat tip to everyone. And even when it's at its Lagrange point, you'll be able to image it. We imaged the Herschel telescope using the Fulks 2-meter telescopes when it was kind of lost for a while, and we managed to recover it a few years ago. So it's going to be one, hopefully, for 10, hopefully more years, that's just going to deliver astonishing science. We could talk about this for days, but hopefully by the next show, as you said, it'll be out there, and then we'll follow this through till April, and then hopefully bring you some of the first images when they come back, and just celebrate really, and absolutely in the wake of. Don't forget, all of this has been done during COVID as well. You think about the challenges. Unless you're working at number 10 and you're throwing a party, but the challenges of just even getting together and doing any real work is so complex. And they've managed to launch the most advanced telescope ever into orbit.